Okay, Assalamualaikum warahmatullahi and very good day. So we are going to continue our lectures on the subject for microcontroller. On the past lectures and past assessments, we went through already some basic stuff of the programming, where you have to engage with two softwares. One is called Microc and another one is called the Proteus. Okay, so for today's lecture, I'm not going to move forward far away, because I think that this is the basic things that I need to improve with you guys, and I want you guys to improve on the basic things of how to do the programming. Okay, so for the last lecture, there are two registers. Okay, two registers. Registers is things that inside your RAM, which you need to change to set up your microcontroller. This is a normal, this is actually an initial stage for all the microcontrollers. You must set the pins that you want to use as either input or the output. For example, right, you are trying to figure out, you are going to do a project for a blinking LEDs. You are going to have 8 LEDs, and you have to figure out which port that you are going to use. For example, you're going to use port B in microcontroller. Then you need to set the pins as the output, because LED is peripherals or things that actually receive the voltage from the controller to turn on. Okay, without further ado, I'm going to proceed with the lectures today. So again, we are going to understand the basic coding of Microc, and then we are going to identify the input output again for the microcontroller. Okay, interrupts will be done in next lecture. Let's proceed. Okay, let me remove this one first. Okay, if you can see, remember, I don't think so you have this experience on the last microprocessor class. This is basically related to the hardware. This is assembly. Remember that this is assembly language, and this one used in Microc. This is C++ language. You can see that the difference is very quite clear, which where for C++ you actually really understand what is the syntax all about. Okay, you can see that here there's no the body is over here, the main body here, whereas the body for the C++ is here, which is you have the void main. Remember that we have this void. This is something that the structure of the C++ programming, and then you have the bracket, and then you have the curly bracket, which is the body. Okay, so over here you can see that again I'm going to keep on emphasize on the trace registers and the port registers. So this is an example of it, but we are going to play around this one. Okay, next one. Let me take out this one first. Sorry for that one. Okay, what is I/O pins? What is I/O pins? I/O pins is input output pins. Why call it port here? Call it port because of in your microcontroller. In your microcontroller, let me double check this one. Okay. In your microcontroller here, for example, here in this example, can I have a better one here? Alright, so here you have the ports. I call it, this is a name. This is not a register. This is a name. This is port B, the grouping. This is port D, the grouping, and this is port C. And you have the grouping for port A and port E. So you can see that the total of the pins are different for the port, different ports. So for example, for port B you have how many pins? 0 to 7, which is 8 pins. Port C start from here, I think. C, RC1, RC0 here, RC3, 4, 5, 6, 7. Port C also 8 pins. and D you have to find out 0 here. 0, 1, 2, 3, 4, 5, 6, 7 also, which is 8 pins. Compared to port E and port A, port E and port A is actually a bit different, where port A, port A, it can be either digital or analog input, and also port E also having the same function like port A. You can see that this is a digital input output can be set up. Also you can set up as the analog input. Same goes to port A. Okay. So here example, I'm going to have that. For example, I'm going to play around with port B. Here I want to play around with port B. Right, port B here, and then you can see that this is the trace register. This is a port register. This is not the name anymore. This is a port. This port register is related to the trace register. Again, the trace register for you to change accordingly to what you want it to do. For example, at port B, this is port B, right? You have RB0 start from here, for example, and then this is RB7. So you want to know that, for example, here you want to have these pins RB1 to be connected to LED. So you have the resistors here, something like that. Alright, so what you need to do is you need to set this register to 0 to make it as output. Remember that I always give this very simple solution. 1 is equivalent to like this, like input, and 0 is like output. It's very simple. So trace is related to this. Okay, then I/O pins is used for peripherals connection, which is this one just now. You can see that you have sort of, this is like a switch to turn on the transistors over here. Then you have the LED, you have the switch buttons. This is for input. You can see that you are going to have the input here, and then this is like a sensor. In sensors is going in, so it's going to be an input. So you can see that this is how it was set up for this kind of peripherals. Okay, so every port has its corresponding trace register. Determine the usage of the pins. You have the trace A, trace B, trace C, trace D, and trace E. So where are all these registers located? So again, if you go back to the chapter 2, you can see this one. I'm going to remove this one first. Hold on. So this is your RAM. You can see that there are a lot of registers that you are going to play with, a lot of them. But today, the one that we are going to play is this one only, the trace register. The trace register here, and then you also need to use port registers here. This is a register. So do not confuse when I talk about a port A, B, and C, and the port related to the register. Okay, so these are the two registers that we are going to play around today. Okay, again, if register is set to 0, then it's going to be output. If set to 1, it's going to be as input. So sometimes when I talk about port, you have to try to figure out which port that I'm referring to. Okay, so this is the one, alright. Okay, next. So the three ports that we are going to play around most of the time for this one is the port B, C, and D, which is an 8-bit wide. Why you call it 8-bit wide? Here you can see that the size of the register here for each port, okay, for all these registers, is the size will be 8-bit size. You can see that basically if you zoom down here, there will be 8-bit over here. You will be like this: 1, 2, 3, 4, 5, 6, 7, 8. So there will be 8-bit of registers, 8-bit size of registers. Same goes to trace. So you have the size will be like this, 8, and then you can see that here is the one. this is, you extract back and put it over here. You can see that port B and trice B all both have 8-bit size, and the trice B is related to RB0. Sorry, what happened here? So the trice B 0 related to B0, trice B is related to port B, and each of the component here, B7, is related to B7. It relates because this register, trice register, is to set up your I/O, and the port B register, when you set up this register, maybe you want to put 1010, so it means that if you put 1 is equivalent to 5 volt out, 0 means equivalent to 0 volt out. Very simple, because you know that in microcontroller the allowable voltage is only 5 volt, so the output is going to be only 5 volt. They are not going to have extra like 10, 12, 20 volt. That's wrong. Okay, your microcontroller only give either 0 or 1. That's why they call it digital, which is 0 or 5 volt. So these are the example of that. So port BC is an 8-bit wide bidirectional port. Bidirectional means it can be either input, or it can be also an output. It's bidirectional. So trice register will determine the pins as input or output. So you can see that every time when you do the coding example here, you must start to trice, which is to initialize the state of your pin. So because if you do not put this one, then you do not know which pin is actually working as your hand, working as your feet. You do not know. So that's why you have to set up first the trice statement after the void main. That is the initial things that you need to do. Okay, so there are port B, C, and D, which is nearly the same. So that's why most of the I/O I'm going to put it over here. Whereas port A and port E I normally reserve for any analog input. It's much better. Okay, so I'm not going to use the analog input because you have the extra resources over here. So just use over here to use the NIO. Next one. So okay, this is the example again. I keep on putting this one, so you guys must understand what it's actually all about. So trice X, trice B, C, D, or A. X is equivalent to that one, and sets the pins on the ports, port A, port B, port C, port D, port E, as input 1, which is you put 1 will be as input and output 0 as the output. So example here, if you are putting trice B 01111, means that this is the right one here is representing the RB0. So going forward, this is representing RB7. So you can see that the last 4 here you are setting up as the output, and the other one here you are setting up as your input. This is example. You can put any numbers here, 1 or 0. It's up to you which pins that you want to work as an input or as the output. So another example here, you can see that trice B I can put like this also, no problem. But I know that the first 2 pins is working as output, the second 2 pins is working as input. Same goes to this one. I know that this is 01, 0 for output or input. So RB1, RB3, RB6, RB7 as the output, and RB0, RB2, RB4, RB5 as the input. Okay, so that is the setting up of your pins by using the trice register. Then, how to give an output here? So by giving you only the setting, you don't have any voltage coming out. Voltage is not yet there. Voltage is what? You don't have. So that's why comes another port registers to be changed. So without changing this one, you don't have any value here, or I can call it a like hanging state. You don't know what's that. So output to port X given that it will affect the pins in real time. So when you have the output only, okay, remember that when you have output here, then you can use the port the port here. If you use as input, actually when you set the port, it doesn't really matters because there's no input out. input, it does not input. So it means that the output to port X is given directly, will affect the pins in real time. So output only. For example here, now you change the port register, port B is equivalent to 0B. This is again, this is to say that I will only put in binary numbers, which is going to be 1 1. Input, I don't really care, just put 0 0. Output 1 0 0 1. Okay, something like that lah. So the first two is 11 1 1. So for example here 1 1 0 0 1 0 0 1. So you can see that when you take a voltmeter here, you measure this one to ground, you are going to receive, this is a 5 volt here for this pin. Same goes to this one. When you set up as 1, you measure it, you can see that the value for the voltage is 5 volt. So that's the importance of having the port registers to be changed accordingly. Okay, alright, let's move. Here, port B 0B 1111 will give all 5 volt output to all pins RB0 until RB7. Okay, so that's the case. That's why this notation is very important, because this is a binary code. Okay, let's move on. So after port B and C and D, you also can use port A and port E, but over here the port A I'm going to use normally for the 6 for the input will be 6 only, right? If we can check this one, is only 5 of them. 1 2 3 4 5 6, yeah, 6 only. So you have the port A again and thrice B. So the other two bit in the register is not used. This is not used. So to set up, you require to change only this one. For example, that you want to change as digital, so you can use this one, RA1, RA4, RA3, which is the port and thrice again. So you can change this one accordingly. So for example here, you want to change you want to set up the input as digital IO, so you can change this one accordingly to 1 0 1. Example, just example, this is nothing, this is nothing, you have to put like this. So it means that your thrice A is equivalent to 0B. You have to put here first 2 0 0, and then you have this one all 1 0 1 1 1 1. So this is the value you set up. So it means that this is going to be your input, this is going to be your output, and this is going to be input. The rest two is not calculated, doesn't care. Okay, so all ports A pins actually act as a digital IO and can be used also for analog input. So you can see that this one AN is denoted for analog input only. Okay, so move on. So again, the same one like port E and thrice is register. So port A, you have only 3 pins. You can see that RE0, RE1, RE2. Okay, you can see that this is the one only you need to change. The rest you don't really care. So this is a thrice E register. So you have to change according to this one. So this one, the rest, you have to read the registers. What is the function of this one? Basically, what's the function of this? It's either 1 or 0. It depends on the data sheet. Okay. So port E has 3 pins and you can configure it as input or output. Port E pins are multiplex with same one like port A just now. It is multiplex with analog input. So thrice E controls the directions of our E pins. Again, thrice E is the one that controlling whether you want to put it as input or you want to put it as output. Alright, let's move on. Okay, this is example here. Let's try to look at this very simple example. I don't want to get you guys confused, so I'm going to change something here. So this is the void main, this is the body. So you have the open bracket, curly bracket, and you have to close the curly bracket. This is a must, else your function, your program is not working. So the first one, the first thing in the programming for the microcontroller, you must set up your port. So this component, this syntax is telling us that you are going to use port B. In this program, you are going to use port B, so we are going to set up thrice B. So it means that all port B is equivalent to output. All of them, each of them is each of the pin because it's only 8 bits. So RB0 to RB7 all as output. So the next statement is, after you set it up as output, you have to set up the voltage out from the pins. So this port B, again we are putting all 0 here, so means that the output for each of the pin here at port B starts at 5 volts. So after that, it will move here. So this is, you can see that this is while one loop, right? So while one loop is, you have to put 1 over here, because this one is telling us that the looping must be continuously looped once it's go in. So this is only done, this is completed once only, means the program will go down, right? So once complete this one, it go to while one loop, so it's going to loop forever here. So in this program, what is actually telling us actually, you can see that the command will be port B is equivalent to invert. Invert means to invert back the port B. This is invert value. This is invert signal symbol. So means that currently your port B, your pins all is actually 0 volt. All of them is 0 volt, right? When you say that the current one going to be inverted, so the invert will be 0 going to 5. So you have to imagine that once it's go to this line, now your port B pins is equivalent to 5 volt. Then it will delay here for 1 second. It will go up again doing the same thing. So currently right now your port is 5 volt value. So what happened here, this is going to be inverse again. So your port B is going to be 0 volt. And it will continuously loop. You can see that it will be like this. And you have to imagine that your LED will be turned on, turn off, turn on, turn off, turn on, and it goes on the list unless you reset it or you turn off the system. Okay, let's move on. So this is nothing. Okay, you can see that here. Let me remove this one first. This is how it works last time. So you can see that how we are going to write down the coding is like this. The same one, you have the void main, open bracket, and then you have the while one loop, which is the loop with open and close bracket. This is the pattern. This is actually the format, the simple format, very basic format. Okay, so you keep on trying in your micro C, then you can see that how it works. Then you have what else? This is another one. You have the body just now. I add this one. This is the call it subroutine. We call it subroutine here. Okay, this subroutine is, you are actually call it as an init main. In your void main, this is your main body, like you will go to this one first. This is, we call this guy and do the same thing. You can see that this is actually the setting up process for your pins and your ports level value of voltage. It's the same thing. You can put over here, or you can put it, or you separate it as a subroutine and you just call this init main. Okay, the main body with open bracket and close bracket, and this is the one while one loop with open and close bracket. So again, this is the same thing. So you can see that here, this one I change it to 0B. You can see that all here port B, this is a 0 volt and this is only 5 volt, the rest is 0 volt. So you can see that from here only one LED is going to be turned on and turned off later. So the sequence, sorry, this is only, there's no invert, so it's going to be always like this. So there is only one pin is going to be turned on, the rest is going to be turned off. Okay, let's move. The rest is related about C++, and I believe that you guys have to go back. I understand this one. You guys have to go back to the C++ class, I mean the C++ notes. How to work on variables. This is all about variables, how to set up variables. This is actually the rules in C++ when you set up the variables. And then you have the loop. Remember that you have the for, while, and do while loop. This is a looping. For example, that we need to use most of the time is this one, while one loop. And then you have if else and switch case statement. So here example is if else and switch case. This is a switch case, right? And this is the subroutine. Just now I show you this one is the same one, subroutine here. Okay, this is subroutine. You can call any subroutine. If you create the subroutines outside from the main body, you just call the subroutine. And this is the way that you want to, maybe because why subroutine is very important, because it's easier for maintenance. You just cannot imagine yourself just write all the codes in the same line in the body. All the means that your code will be very long. It's very hard to troubleshoot. So that's why when you separate it to subroutine, then you know that some of them need to be changed only at the subroutine. That's the most part of it. Okay, stack I'm not really going to keep on. I'm not going to talk about this one yet. So for this lecture today is completed, but I'm going to work with you guys on the Micro C again. So here, let's try the Micro C again. Micro C again, Micro C Pro. So let's try. Alright, so again, you can start the project with a new project. So it's up to you here, new project. You can put anyway, as long as you understand. So new project here. I just want to go back to the new project. So standard project. You can see that the name PIC is correct. And before you go, you have to check your PIC device over here. This is 20 megahertz. This is correct. Next, this is where I want to browse and put it over here. Where is it? So coding example, lecture 4. Make new folder. Lecture 4. Oh, then we know that name number is not allowed. So lecture, okay. So change device clock to 20 megahertz. Then next, no need file anything to add up. Then finish. I want to check. Hold on. PMP. So when you create this one, right, the folder is still empty. You can see this is a folder I put just now. So you have this one, void main. So let's try B is equivalent to 0B 11110000, and then just port B is equivalent to 0B 0000, because I don't want to have any voltage out here. So this is the two lines that I write down just to have a look. Then you have here nothing had, right? Nothing here actually. So just save this one. It will ask you to save the file. Just this is my project, save. And then you can see that this is the only file, which is .c file. Only there. So when you compile it, it's going to run everything. Build project, build. So there's no problem. Finished successfully my project. So you can see that after that, your project now completed all of them. The one that you're going to use in Proteus is this file, project.hex. Okay, project.hex. Okay, let's try to do something about the LED again. So you are going to have the wall one here. Then you have the curly bracket open and close. Okay. So this one going to say that now I want to do port B is equivalent to just now. Again, this is the invert, right? Just now, port B. Okay. Delay MS 1000 and OK. So compile it again. You must compile every time you change. So now got problem here. You can see that there's no semicolon found. So you compile it again. There's no problem here. Alright, let's go to Proteus. Okay, go to your ICs, then PIC here, right, this one. Then what else we have? You want to add LED, just put the yellow ones. Then you have the resistors, then you have the button switch. I just want to show you how button works. This is push button. What else? I think this is all. So let's go for the first one, PIC. So I'm going to use the last 4 to turn on. Alright, so here you must get the ground. Right, then you have the again the component here. The component will be like this component mode. So this is a resistor. You have to change, you have to add up. So now you have to change this one to 1 kilo because 10 kilo is quite big. Then what else you have to do? Now you have to connect all the lines. Oops, escape. Here, go to LED, go to this one, here, to LED, to this one. Okay, done. This one complete. Alright, then you have to get your program files. The program files is from your file just now. Coding example, which is this lecture. This is project hack. If this is the latest one, you have to find out. You have to check. This is the latest state modified. Which every time you compile it, you have to check this one. This is the time. Okay, this one correct. Change to 20 megahertz. Do not forget this one. Then OK. Alright, now you can click the button. You can see that it's blinking on and off. So if it is red, it's actually 5 volt. Blue is this one. So just go back to your code. The first 4 I set up as input, right? So there's nothing here. You can see that it's gray. Let's try to put something. What happened if I'm using the input and also have the LED? What happened? This is first. So input is going out, so it's going in, sorry. So I'm not sure what happened here. Let's try to have a look. Alright, here this is 1 kilo. Alright, let's try to see. Run again. You can see that this is not changed. Why is blue color? Because this is input, right? Input is going in. So the input here is coming from this ground. So it is 5 volt here, which is wrong. You cannot change anything. So today a new one that I'm going to teach you how to work a switch. Work on a switch. So instead of having this one as the output for LED, I'm going to have it as a switch. So this one I'm going to put here. Okay, this is a switch. This is going to be here. So this is going to be push button. Oh, sorry. Here button. Okay, button will be here. Okay, so you have to imagine this is a switch. So right now the input will be directly to the delete power. This one, sorry, not this one, this one, power. So this is the circuit for the input here. If I do not push this button, the value will be coming here. So I have to put a resistor over here, else if I push this button, then it's going to be a circuit because power supply will go to ground. So that's why I have to put a resistor over here. So it means that when you push this button, the value will take from the ground. It will not short circuit directly to the power. So let's try. So you can see that now it's red, right? Red is because the input is coming from this one. This is 0 volt and this is 5 volt because of here, and the input will be 5 volt. So what happens if I push this button? The value now will be changed to 0 volt. This is a switch circuit, and this is how you have to build a circuit on the board. This circuit can be used at this pin 1, the master clear. Remember that if you turn on this button, it's going to have a low active version because master clear is bar, so it will active if you push your button and get a lower value over here. So this is the things that you are going to use later. For example, you want to have a condition if you push a button. That's why later you are going to learn about the if-else statement. If the value from this port is equivalent to 0 or 1, then you are going to do something. That's the if-else statement coming in. Okay, so I want you guys to master all this diagram, this circuit, this input or this output. You have to understand this one. Okay, alright. So the things that I'm going to touch for the before I stop the class is this one. Let's do this one. If you are going to use the convention to set up the tri-state for the port trice, for example, right? Trice P is equivalent to 0. This is not equivalent to trice P. For example, this is 0 means sorry, this is going to be equivalent. This is going to be equivalent. This is going to be equivalent as 0B 0 0 0 0 0 0 0 0. This is RB0. This one you cannot see because I don't have the 0B at the front, so means that this is the one that you declare it using decimal numbers. So if you are expert, you can use this one, because for example here, if I put trice B is equivalent to 1, this is not the same one as trice B is equivalent to 1 1 1 1 1 1 1. This is totally wrong. This is equivalent to 1, and if you use this number at your calculator, this is not going to be a value of 1. So you better use 0B. I don't want you to jump, but if you are expert enough, you can use the direct. For example, you want to do trice B is equivalent to 10. So this is going to be equivalent, which pins that you're going to change is equivalent to 0B 0 0 0 0 1 0 1 0. This is 8 and this is 2. 8 plus 2 is equivalent to 10. Okay, so that's the case. So make sure that you know which one is decimal, which is binary. Representation you must put over here. So I advise my student, because you are still new, so please use 0B for the usage on the what do you call it, declarations of your pins. So better to use binary convention. It's much easier. Okay, I think that's all for today, and do not forget to do the assessment. So you're going to have another 10 questions, and all the best for you. Good luck.